Alright guys, so this is going to be our last method of solving quadratic equations, and it's called the quadratic formula. So let's think back to all the methods that we know so far. There's graphing, and wherever the parabola hits the x-axis is our solutions. There's factoring, where we set each term once it's factored equal to 0, and those are our solutions. There's the square root method, which I'm allowed to use only when there is no b term, so there's no linear term or x term. And then there's completing the square, which always works. So the only method so far that always works is completing the square. Now graphing, of course, would always work, but sometimes it's not very pretty unless you have some type of computer program graphing it for you. Now, what if you don't want to do completing the square, but none of the other methods work? Well, then we can use the quadratic formula. So here it is. Here is the quadratic formula. This is the formula that will work for any quadratic function to help you find the solutions or zeros, roots, whatever you want to call it. Now, yes, you have to memorize this because I will not give this to you. This is expected of you to know. So we will be reciting a couple songs that helps us remember. Now, whenever you are using the quadratic formula, you must have it in standard form, which is ax squared plus bx plus c equals 0, where you know a, b, and c. So the reason why sometimes people don't use this is because people can get confused or mess up easily with their arithmetic whenever they are plugging in a, b, and c. So if it's factorable, it's definitely easier to factor. If it's a square root, it's definitely easier just to take the square root. But if all else fails, this will work every time. So I'm sure you are wondering, where did this crazy formula come from, right? How did they figure it out, and how do they know it works for every single quadratic? Well, if you really want to know, I will be more than happy to show you. Or if you want to take some initiative, you can go to page 240 in your book, and it shows you the proof. And it's pretty much taking the quadratic function here, ax squared plus bx plus c equals 0, and then leaving a, b, and c there. They complete the square, and then that gives us the quadratic formula. Alright, so here we go. We're going to find the solutions. So the first thing I need to do is make sure that this is in standard form. So I need to go ahead and move everything to the left-hand side. Okay, now you can go ahead and double check. This is not factorable. There's no way for me to arrange the factors of 3 or 2 so they will add or subtract to give me 4. So I'm going to go ahead and list all of the A is 3, B is -4, C is -2. So plugging in, x equals negative b, so be careful there with that double negative, plus or minus b squared minus 4 times a times c all over 2a. Most common mistake, people forget to put the entire thing over 2a. Alright, so then evaluating, I get positive 4 plus or minus. Underneath the radical there, I'm going to get 16 minus, well, 4 times 3 times -2 gives me -24. All over 6. Okay, giving myself a little bit more space. Now simplifying a little bit, x equals 4 plus or minus the square root. Now I have 16 plus 24 all over 6. Now obviously you don't have to show all of these steps, but I don't want you to get confused and miss anything. Square root of 40 all over 6. Now obviously, hopefully by now we know that the square root of 40 can be simplified. So I'm going to go ahead and simplify that. So x equals 4 plus or minus, well, 40 can break down into 4 and 10. So the square root of 4 is 2 all over 6. Now you may be thinking, yay, we're done. Not quite, because this guy, and this guy all have a GCF, right? So I need to make sure I reduce those, okay? Now let's say just these two had a GCF. You would want to split the fraction, reduce those, and have something plus or minus something else that's separated. Now also, most common mistake is people think that they can reduce what's underneath the radical with what's under the denominator, and you can never do that. So please don't do that. Alright, so simplifying, 4 4, 2, and 6 all have a GCF of 2. So when I do this 4 divided by 2, I get 2, plus or minus. This 2 divided by 2, I get 1. So I'm just going to not write that. And then when I do 6 divided by 2, I get 3. So here are my answers. And as you can see, I have 2 real answers, right? I have 2 plus the square root of 10 divided by 3, and I have 2 minus the square root of 10 divided by 3. I'm okay with you leaving it as 1. As long as everything reduced together, then you can leave it as one fraction. Alright, so believe it or not, a lot of real-world situations use quadratic functions to model what is going on. So in this particular case, you sell wrapping paper as a charity fundraiser. The equation p equals negative 6x squared plus 280x minus 1200 is going to model your profit, p, as a function of the price, x, per roll of paper. We want to figure out what's the smallest amount in dollars we can charge to make a profit of $1,500. So that means I want this p over here to be 1,500. Okay. So this is a little different. The problems we were doing before, we wanted it to be 0, right? Like when they hit the ground or when the speed was 0. Here, we want the profit to be 1,500, so that's what we're putting in for our y, and we want to find the x that makes our y 1,500. But same process. Now, obviously, I don't think this is going to factor, so I'm going to bring everything to one side. We still need it set equal to 0 to be able to solve it, though. So I'm going to bring the 1,500 over. So negative 1,200 minus 1,500 is going to give me negative 2,700. Now here's my quadratic function. My a is negative 6, my b is 280, and my c is negative 2,700. So plugging into the quadratic formula, which hopefully you will soon memorize, we have x equals negative b, so negative 280, plus or minus b squared, minus 4ac, all over 2a. Okay, everything's over 2a. Now, I hope you can see why, if it's factorable, we want to factor, because this is a lot of computation and you can make errors lots of times along the way. So, negative 280 plus or minus 280 squared. It's going to give me 78,400. And then I'm going to do 4 times negative 6 times negative 2,700. All right, all over negative 12. All right, simplifying that. All over negative 12. Okay. Now, at this point, because it's a real-world situation, we actually want to evaluate what these values are going to be. We don't want to leave a square root, right? Because we're looking for the cost per roll. So leaving it as a square root doesn't really make sense. So we are going to evaluate, which means we're going to do x equals negative 280 plus the square root divided by negative 12. And we're going to do x equals negative 280 minus this square root divided by negative 12. So we're going to do that computation in our calculator. So this is what we're going to get for x, but we got to remember that in the question it said what is the smallest amount that we can charge per roll that will make the profit $1,500. So that means I can't give both of these answers. I want to give the smallest one, which is this one, right? But of course, put it in context, and let's round to the nearest cent here. So it's going to be $13.62. So that is my final answer. Yay! All right, so now it's your turn, so go ahead and complete these and put your answers in your Google form. Please make sure that if you have to use a square root symbol or plus minus, just use your mathematical vocabulary and say it in words, whatever it is in symbols, unless you would like to copy and paste the symbols from the internet, which is also possible.